Bioreactor and fermentation. Aerobic fermentation. These reactors should have adequate provision for supply of sterile air and also need a mechanism of stirring up and mixing the medium and cells. Aerobic fermentation is usually a shorter and more intense process than anaerobic fermentation. Oxygen limitation is a major problem in aerobic fermentations because oxygen has low solubility in water. To keep the culture at a high cell density, a high agitation or aeration rate is the most commonly used strategy to improve oxygen transfer rate. Anaerobic fermentation. It occurs in the fermentation vessels once the oxygen is discharged and replaced with nitrogen, carbon dioxide, or another byproduct of the fermentation process. Anaerobic fermentation is usually a slower process. The most important industrial fermentation is the anaerobic production of ethanol by Saccharomyces cerevisiae and other yeasts. Solid state fermentation. It is used by several industries like pharmaceuticals, food, textiles, etc. to produce metabolites of microorganisms using solid support. It is used for the production of value-added products like antibiotics, single-cell protein, PFAS, enzymes, organic acids, biopesticides, biofuel, and aroma production. The support used is especially grain brands, de-oiled oilseed cakes, and other substances like. Initially, mostly fungi were used in such fermentation. Later, many bacterial species and yeast were used. However, bacteria and yeast, which require higher moisture content for efficient fermentation, can also be used for solid state fermentation, but with a lower yield. Steps in solid state fermentations are: first one, pre-treatment of substrate raw materials either by mechanical, chemical, or biochemical processing to enhance the availability of the bound nutrients and also to reduce the size of the components. Example, pulverizing straw and shredding vegetable materials to optimize the physical aspects of the process. Second one, hydrolysis of primarily polymeric substrates, example, polysaccharides and proteins. Third one, utilization or fermentation of hydrolysis products. Fourth step is separation and purification of end products. Submerged fermentation. It is a process involving the development of microorganisms in a liquid broth. There are two common methods by which submerged fermentation takes place. They are batch fed fermentation and continuous fermentation. Till date, submerged fermentation is the most accepted technology for industrial production of primary and secondary metabolites. Some common substrates used in submerged fermentation are soluble sugars, molasses, liquid media, fruit and vegetable juices, and sewage or wastewater.